Right, okay, hi guys, this is Mike T. Nelson, and today we're going to be talking about how to interpret research papers, because as we know, with personal trainers there's a lot of misinformation around and people don't know how to look at credible research. Okay, so Mike, take it away.
Hey guys, thank you very much. I'm Dr. Mike T. Nelson here, and the reason I think this topic is important is because there's a lot of misinformation in media and that type of thing, and depending on when you watch this, lately protein and meat is horrible bad and will kill you faster than cigarettes, and I don't know, there's always something that's coming up. A while back was fish oil was horrible, give you prostate cancer. And so I think it's important to look at, if you can, the actual research studies and what was actually done. And that doesn't mean you're going to be an expert per se at reading them, but if you have some idea of what you're looking at, that's beneficial. So the first part I always tell people is go to PubMed. It's just PubMed, PUBMED.org. And it's a free resource, doesn't cost you anything. You can get access to it over the internet. So every time I describe this to my students, I always have a hard time not giving them one of my day, we had to go, to the library and find stuff, and, we had card catalogs, and because I had a few students once complain that it was really hard to find studies on PubMed, which it can be if you don't know what you're looking for. So it was really hard for me not to give them the whole lecture of, we used to go to libraries and look up periodicals and go through this whole thing. So the nice part about PubMed is that, in essence, it's just like a Google search. So you can type in what you're looking for. And if you're not really sure, just guess, right? I mean, so if you're trying to look up like protein safety, right? So even if you type in protein and safety, you'll probably get a fair amount of items that are going to pop up. So that's really nice. The other part that most people don't know about it is, depending on how it's configured, a lot of times if you look down the left side, you can pick what's called limiters. And this means if I only want to look at human subject studies, or if I only want to look in the last 5 years or 10 years, I can put those sort of limiters in, and now it's only going to return to me messages that meet those qualifications. So initially what I do at first is make it as abstract as possible, and then I will kind of narrow it down depending upon what I find. So if I find that there's too many, then I'll start to limit it down. Sometimes you won't find a lot of humans, studies, so you have to look at some animal studies, and that's okay, as long as you know the limits of it and that type of thing too. So that's the first thing I have people do. If you're not really sure about anything on a topic at all, you can either pick reviews or type in the word review, and that'll give you a pretty good basic start. And a lot of times, a lot of people are publishing stuff more open access. So how open access works means that when you, the researcher, send in the research, you or your lab pays a fee in order to have it published. Because if you run a journal, there's costs associated with, the process and having editors look at it and all that kind of stuff. Unfortunately, peer reviewers, I do a bunch of peer reviews. I don't make money doing that, but there's costs associated with it. So a lot of times how journals would make money is they would sell you a subscription. That's how they would cover costs. Some other ones do what's called open access. So when I submitted my research on energy drinks to the Journal of International Society of Sports Nutrition, I actually paid their fee, after it was peer reviewed and accepted. But the good part now is that anyone can go and pull up the actual full text of the article. So most of the time you can only get the abstract, which is just a short version of it. If you look for open access, you can get full access to the whole study. So a lot of people who are not associated with the university, who don't have access to full studies, you can get a lot of open access stuff. So the free full version a lot of times, which is kind of nice. So I'm sure you've probably pulled up some of those before too, which is good.
Yeah, I mean, I've done some research, but I need to get back into it really, because I did a lot when I was doing my sports science qualifications, but it's something I need to stay more on top of, because that's the next one I'm going to read, is your energy drink study.
Oh, cool. Thank you.
I'll just have a look, because I used to drink like ridiculous amounts of Red Bull for ages, and I'd like to see what I've done for myself.
Yeah, yeah.
With quick question, with like animal and human studies, because you said about knowing the limitations. For someone that's just kind of getting into researching and reading studies, what are the limitations between, like, for example, a human and an animal study? What? Yeah.
Yeah. The hard part is for most people, to be perfectly honest, they're probably not going to know. And even though I do research, I work with clients and stuff, there's a lot of the animal research stuff that I don't know how it applies to humans, because there's obviously a difference in body weight. There's looking at a lot of mouse studies and rat studies, big difference sometimes in metabolism. So one of the areas that people just lose their mind on this is related to high fructose corn syrup, right? So, if you read a lot of the animal studies, oh my gosh, you would think that it's, the most horrible thing ever. But you have to realize that the amount given to them compared to a dose given to a human, even if you just scale up for body weight, that's not always exact, but massive, massive amounts of huge dose, right, given to the little buggers. So it's the old Pericles quote that, the dose makes the poison, right? So what's fascinating is even some things that are very, very toxic, given to even humans in very, very, very small amounts, actually have some beneficial effects. But anyway, the scaling a dose isn't a direct scale up. That's one thing. So normally animals have a much, much higher dose. And that makes sense if you started doing research, right? Because you want to know, does this affect it at all? So you're going to start at a high dose and then over a series of studies, probably walk the dose down, assuming you still see an effect. So the high fructose corn syrup also, you have to look at the individual metabolism differences too. So in rats, they have a very high level of what's called DNL, de novo, lipogenesis. And that process is taking the fructose, converting it in the liver to fats. And in rats, their DNL rates are much higher than humans. So they convert a lot of that high fructose corn syrup much faster. So their metabolism isn't directly the same as a human. So that's kind of the two main things to look out for are dose and then sort of the individual metabolism. And at a base level, the most simplistic argument is that, well, peoples aren't really rats, right? And what really, really bugs me the most is that when a compound is available to human consumption and is still being tested in animals. So an example is CLA, right? CLA was this supposedly wonderful, amazing fatty acid, and a lot of the original research was done on rats, which makes sense, right? Because if you're going to start, it's easier to do research, easier to get approval, easier to obviously dissect them and see what went on, do more mechanistic studies. But I mean, they've been doing those studies for years and years and years. And what they find is in rats, CLA is like freaking amazing. It has an amazing ability to repartition. The rats get leaner, they get stronger, body composition improves. But when they did the human studies, for the most part, it's pretty worthless in humans, in my opinion. Doesn't really seem to do at all, doesn't match, many of the rat studies at all. And what bugs me is that there's still a lot of research that are still doing rat studies on that, even though it's been in human consumption for a long time. There's plenty of rat data. We don't need any more damn rat data. It's like, are you trying to make, wonderful, super strong, furry rats, or, are you trying to figure out if it's, anything worthwhile in humans? Shameless plug too, if people want more information on that. There's a great book from the ISSN that talks about fatty acid metabolism and supplements and stuff. So I did a little chapter on there on CLA.
Awesome. We all love a shameless plug. That's all good.
Yeah.
So with, for example, if we were going to look up a certain study, let's say about whey protein, are there any things that you should look for to ensure that the study you're reading is valid? Like, for example, does it have to be peer reviewed? Are there certain things you should look for?
Yeah, there's a whole list of stuff, but a couple of the ones that, if you're thinking about it from someone who just doesn't really have much of a background, pretty much most things on PubMed, for the most part, have been peer reviewed. Once in a while, you get some abstracts that have only been presented at a conference and that type of thing. The downside is that there are different levels of journals, and depending on what area you're in, they have what's called an impact factor. In general, the higher the impact factor, the better the journal. Impact factor is not perfect, but it's kind of a crude marker. I usually just tell people, just if you're not sure, ask some people in your field what they would say some of the top journals are. Or if you find a study that doesn't seem to match anything else and it's in some bizarro journal you've never heard of, ask around and see if it's a reputable journal. It doesn't necessarily mean that it's a bad study offhand, but I also then look to see, has that line of questioning and everything been repeated in the same journal, or has it showed up in any of the more top tier type journals? And has it been repeated by different labs, right? So you may find one oddball study in some bizarro journal that was never replicated anywhere else, right? So even though that may be kind of valid, which is debatable, it doesn't seem to match anything else, right? And so what you're looking for ideally is a consensus in the literature. The other part to watch out for too is populations. So if you're looking at human studies, there's a massive difference between people who are training, who are healthy, versus people who are unhealthy, right? So I say it's a big difference between athlete metabolism and couch potato metabolism, right?
Mm-hmm.
So a perfect example of that is just carbohydrates and sugar, right? You take someone who just doesn't exercise much at all, probably eats more calories than they should, and you give them a huge amount excess of sugar, even large amounts of carbohydrates, they tend to not do very well. If you take an athlete and you give them higher amounts of carbohydrates, in general, they tend to be, pretty okay with that, assuming they're pretty active and healthy. So even the same exact thing given to two different populations can be a little bit different. So I always tell people, when you look at the subjects, look to see if they were trained or untrained. If they're not trained, that doesn't necessarily mean that their data is all bunk and not useful. Again, it's what were they looking at, right? So the big thing that drives me just bonkers is people will take completely untrained people, put them on a new training study, and then in 8 weeks, they gain strength. And people will run around and hold up one study and say, oh, this is the greatest, training study that's ever been done to man. And, as you know, you can take anyone and have them do almost any type of overload. If they've never done it before, they're probably going to get better, right? Mm-hmm. So then you'd want to look at, did they only look at strength markers, or were they looking like a next level down? Were they looking at some type of mechanism, right? Were they trying to see what exactly is going on in these people? And for untrained subjects, some of those things are a little bit more useful, right? Because the flip side is, and a lot of people will say, well, this is done on only untrained people. Now, to a trained population, it's completely worthless. Maybe, maybe not. If there's no studies in a trained population, the answer is it might apply to trained people. Don't really know yet. And if you're running a research study, to get all these elite level, highly trained people is really, really hard to do. So in my study, I wanted to use more trained people actually, and I looked around at trying to get them. Pretty much wasn't going to happen for the most part, at least for that study. And in the end, it probably wasn't that applicable. So I'm looking at the consumption of energy drinks in more of the average person in the population, so it wasn't directly applicable either. So if I went to my good buddy Cal Dietz at the U and said, hey, I want to run some new research study. I want to take your athletes and pull them off your complete training program. I want to stuff needles in them and measure a bunch of stuff. I want to do all these things for, let's say, 8 weeks, and they can't do their normal training because that's going to mess with my study. He's going to tell me to get lost, right? And I understand if I was in his job, I wouldn't let me touch any of his people at all, right? Because he's getting paid to get a result with those athletes. He's not getting paid for them to be in my research study. And his job depends upon him getting a result with those athletes. So a lot of times is it better to use trained people if you're trying to make observations in a trained subject population? Of course, right? Because that's going to match better. is it a lot of times realistic to expect researchers to snap their fingers and have those people just show up in their study overnight? No. So it's a lot harder. So caveats with all that is look at the patient population, see if it's specific. If they are untrained and there's no trained data, proceed with a little bit of caution. Doesn't mean that the data is completely worthless. It just means that it may not transfer over. If it's a new study, we know based on just standard principles that they are going to get a pretty good result by doing anything. If it's more mechanistic, now we may have some further insight into why they actually got those results. And that may be useful, caveat being, of course, it would have to be replicated in a trained population type thing too. So
Good times.
a little bit of a sidewise answer.
That's all good. So out of the, let's say for just general personal trainers with not much kind of scientific background, what journals would you currently recommend, do you think, for them just to keep up to date with research and information?
Yeah, that's a good question. There's so many out there now that it's hard to keep track of all of them. I would say, just given my bias, if people want a wide variety of topics. So some of the top ones that I read, which again doesn't mean that they're the most exclusive ones ever, Journal of Strength and Conditioning Research, right? So if you're a trainer, it's put out by the NSCA. If you're a member of the NSCA, you can get their journal for free. You can still get abstracts online. Very much specific to a lot of training studies, training population, training physiology. So I like that one. MedSci and Sports, that's probably one of the top journals, I would say, in terms of high quality research. It'll vary from cardiovascular to physiology type stuff. There used to be a lot more cardiovascular. They're kind of getting a little bit away from that. But some of the reviews that they put out, I think it's like 3 times a year, they'll have a little subsection of reviews. Those are really, really awesome. A lot of times a little bit more heavy mechanistic type stuff. I would say the Journal of International Society of Sports Nutrition, especially for people looking at supplements. And full disclosure, I work on there, or I don't pay me for it, but I'm one of the editorial board people. It's open access, so if you just type in, you look for I think it's the issn.org, I think. Open access, so people can go there and look. They have a lot of position stands that are really, really good. So if you're looking for what is the current position stand on creatine, I helped with one on energy drinks. I think there's meal timing. There's all sorts of them. But if you go on their site, you can find them. So if you get a question about, what is the effect of meal timing or creatine, getting one of the position stands for free and just downloading it will give you a pretty good head start. Like any other research, some of it's a little more biased one way or the other, but at least you can read it, you can look, you can follow up with the individual studies if you wanted to. There's a whole bunch of other journals, I think, that are really good, but I think if I had to narrow it down to just 3 for people to kind of look at that cover kind of 3 main areas, those would probably be my top 3.
Okay, awesome. I'll put them in the description of this video so people can find them. I was just writing them down. So, and then in relation to kind of like you just said, for example, meal timing, that sort of thing, are there any persistent myths that you see at the moment? For example, the paleo diet or fasting or official macros. Is there anything out there that PTs need to be aware of that there's research that kind of goes against the popular grain of thinking?
Oh boy, there's all sorts of stuff. I think the thing that people have to remember too is that I'd say, so if we pick on meal timing and timing, right, because that's the big popular one now. I know Brad Schoenfeld and Ellen Oregon and James Krieger wrote a very nice review that's in JISSN talking about a meta-analysis of timing. So overall, I thought it was very well done. If you read it, my bias is that it's a little bit more showing that protein is beneficial and timing probably not as beneficial. I would agree that it doesn't mean that timing is utterly worthless. But even within those studies, right, there's only ever been literally a handful of studies that have only looked at timing. And by only looking at timing, meaning like the classic study that Paul Cribb did, is you have some type of beverage that's given either before and after training in one group, and then that beverage is given in the morning and at night in the other group.
Mm.
And the same amount of calories, everything else is identical. So the only factor that you would change then would be timing. So studies that have been set up like in that format, Jay Hoffman did another study, there's really only a handful. There's a whole bunch of studies showing that protein before and after training has specific types of effects, but sometimes they didn't give the other group protein. So you have one group that had higher amounts of protein than the other group. And even within the literature that only looked at timing, the results are pretty, split. So Paul Cribb's study, famously showed pretty massive effect. Very well done study. They used DEXA. It was in more high-levelly trained people, so that may be one of the reasons for the result.
Mm.
So the takeaway of all that is that people always want to go, okay, well, because of this new meta-analysis, timing's horrible. It's just not worthless at all. And then other people go the other side, and then, well, timing's like the greatest thing ever, right? If your anabolic window magically closes at 2.1795 hours, well, you're screwed after that. There's nothing you can do. And neither one of those are really true, right? The truth is probably somewhere in the middle. Do you have to be uber worried about getting in protein, a split second after you're done training? I don't think so. I mean, there's studies showing that protein synthesis stays elevated for 24, maybe even 48 hours. Do I think in most people is it beneficial to do that? I would say yes. There's no research I can find to show that it's detrimental, right?
Mm.
So if you did it, you may not get as much benefit as you think, but there's no research to show that that's actually bad, right? And you could argue that by doing it then, that may allow you another time later in the evening or a few hours later, depending on when you train, that you could repeat that process again too. So
Yeah.
I think and it's like anything else, right? So the more science we have come out, the more we'll learn about it. But even to do those types of studies, I mean, like the study Paul Cribb did, very expensive, very time intensive. And so they're not things that are easily done either. And, I think in general, if you were to pick, I would say quality of what you eat, quantity, and then timing. And we have to keep in mind that in the real world, if I tell someone to change just those things all at once, so I tell people a lot of times, if you're training hard, have more protein and carbohydrates before and after training. If you can move most, not all your carbohydrates those times, I think you'll see a better effect.
Mm.
Anecdotally, do I see that's true? Yes. Does that mean it's purely a timing effect? I don't know, right? Because in doing that, I have purposely changed probably what they eat. I've also usually changed the quantity, and now I've also changed the timing. So in the real world, I've kind of changed all three at once. In a research study, that would be hard to figure out what had the biggest effect.
Yeah.
In the real world, what I care about the most is the actual effect, right? Because people pay me to get them a result, right? They don't really care that much about why it happens. So I think we have to kind of be careful of that too, because a lot of people then assume that, oh, well, you think it's all because of nutrient timing. Probably not. But I've also know I've changed other things too at the same time. So.
Mm. Okay, so my my final question really is about fasting and
Yeah.
what kind of research you found and your general opinion on fasting as like a dietary protocol.
Yeah. There's not a lot of research on it, to be perfectly honest. There's some really interesting studies looking at Ramadan, as a form of fasting. So those studies are very interesting. There's some very interesting mice studies. I know one guy is publishing a study that should be out this year. It was a human study looking at fasting that's got some pretty cool results. In general, my bias is I think it's like anything else. I think it's useful, but I think people take it too far to an extreme, right? So I get weird emails from people that are like, oh, you're the guy who likes fasting. Don't you know that decreases muscle protein synthesis and blah, blah, blah? And I'm like, yeah, so it does, right? I mean, I've never argued that people are going to get, massively huge by fasting all the time, right? This doesn't make any sense, right? But if you're trying to alter your body composition and potential health, I think there are benefits to it. So in terms of fasting, I would say it's not consuming anything that has calories. My preference is 1 day a week, work up to a longer fast. So initially you may only be doing 10 hours and then the next week 14 and then 16. Don't go from eating every 2 to 3 hours to not eating for 24 hours overnight. Your body's going to have a hell of a time with that. What is really interesting, and I did find, unfortunately I don't have it in front of me, so I can't give you the researchers' names, but people email me, I can get it to them, that fasting doesn't seem to mess up carbohydrate metabolism as much as very long periods of low carbohydrate, high fat diets. And that may explain a bunch of the research that shows that low carbohydrate diets don't really show much benefit for aerobic training athletes or endurance athletes. And what's cool about the fasting is that it doesn't seem to mess up carbohydrate metabolism. So I've been using fasting just more ironically, and I used it with some endurance athletes, and I didn't see much detrimental effects. And I was racking my brain forever trying to figure out why I didn't match any of the literature. So I think in the new literature we'll see coming out, we'll see that low carbohydrates are probably not the same as fasting from a performance standpoint. So I think a bunch of research in that area will be really cool. So what that means to the average person, I use fasting as a way to drive down insulin levels. Lower insulin is going to push you to use more fatty acids, right? So if you want to get leaner, you want to do more aerobic type performance, that's going to be beneficial. The nice part about a longer period of fasting is that it helps upregulate all those processes. So hopefully they will kind of stick around a little bit. And it doesn't seem to screw up carbohydrate metabolism. So you kind of get the benefit of both. The one thing I don't like is that some people then go, well, fasting's the best thing ever, so I'm just going to do it all the time. I'm going to fast 16 hours a day. And, oh, my training now sucks. I don't know why. It's like, well, if you're fasting for a vast majority of the day, may that help you get leaner? Possibly. I don't think you need to go that extreme. But at some point, it's probably going to impair your performance. And so that's, I think, to the detriment. So in a nutshell, I think it's useful as long as people are very gradual in their approach to it and they use, the minimal effective amount, right? So either my preference, work up to one longer day, or in some of my clients, I actually have them play around with overnight fasting. If they're not super hungry the next morning, skip breakfast and then go on with your normal lunch. If I have them do that every day, no, a lot of times I have them get up and within 30 minutes have 30 grams of protein, right? So a lot of it is just a way of moving things around a little bit. And what I find is it's just easier for most people to do. If you put someone on a very, very low carbohydrate day or even a low calorie day, it seems to be much harder for them to do that as opposed to a day where they just fast for a percentage of the time.
Good times, perfect.
Yeah.
Right, so thanks for your time today. And then what I'll do is I'll upload this video. I'll put all of your kind of links in at the bottom.
Cool.
All the different journals and obviously your site and everything. And then what I'll do is I'll drop you a message later on and see if we can arrange another one if you like, and we'll just kind of do another topic.
Cool. That'd be awesome.
Good times.
Thank you very much, sir.
Have a good day. See you later.
You too. Yep. Bye-bye.